If you pay any attention to the world of robotics and spend any time watching science fiction, you probably know that there's a big difference between what robots can do on screen and what they're actually capable of in real life. Today's guest is someone who's working to bridge that gap. Dennis Hong is a mechanical and aerospace engineering professor at UCLA. He's also the director of the Robotics and Mechanisms Laboratory, or ROMELA. His robots range from floating balloons with spindly legs all the way to thick-thighed humanoid creations that dominate on the soccer pitch. He recently sat down with me to talk about these inventions and to share how he made a custom robot for the new science fiction movie, The Electric State, which is out today on Netflix. Here's that conversation. Thanks so much for coming on to chat today. It's great to have you here.
Thanks for having me.
I understand that you just helped work on some robots related to Electric State, and maybe based on some interviews I've seen of you, that was kind of a full circle moment because of what got you interested in robotics, and maybe relevant to some things in your background today. So would you tell us more about that?
Yeah, absolutely. So this is a true story. When I was 7 years old, when I was a kid, I watched the movie Star Wars for the first time. Episode 4 was the first one. I watched that in the Hollywood Man's Chinese Theater, and all the spaceships and all the lightsabers completely blew me away. And I completely fell in love with the movie. But if you remember in the movie, there's two robots in the movie. They call them droids. Everybody knows C-3PO, the humanoid robot, and R2-D2, the one that looks like a trash can. Completely captivated me. So on my way home back in the car when I was 7 years old, I told my mom and dad, I said, I'm going to grow up to become a robot scientist, and I follow my dreams, and I'm here today. So again, this is my man cave, and you can see all my Star Wars collections in the background.
Very cool. So tell me a little bit about what you did with Electric State.
Sure. So I'm the director of ROMELA, the Robotics and Mechanisms Laboratory at UCLA. We build so many different type of robots: climbing, jumping, rolling robots, humanoid robots, amoeba robots, chemically actuated robots, you name it. We come to our lab next time. I can show you all the really, really fun stuff.
I would love to, yeah.
But for this one, it's a little bit different. There's a new movie, The Electric State.
The bot rebellion was ugly. When the robots deviated from their assigned task, we banished them to the electric state.
It's actually a graphic novel, one of my favorite graphic novels. And the Russo brothers, you probably know the directors, they were making a movie, and I got to be a part of the creation of this. In the movie, there is the main character is a robot called Kid Cosmo.
How would they possibly understand our best interests?
My brother. He's out there somewhere.
And we got to build the actual Kid Cosmo for the movie.
Very cool. And were there any unique challenges to, creating that kind of, sort of entertainment inspired robot versus the, very functional humanoid robots that you sometimes work on in your lab?
Absolutely. Where do I start? Let's actually start talking about the beginning. So I was a professor at Virginia Tech for 11 years, and I joined UCLA about 10 years ago. And UCLA, we're in LA, there's Hollywood. So one of my main things that I wanted to do is try to connect the film industry with the robot industry. I met a lot of really, really famous movie directors, casting directors, even producers, and I showed them our robots, jumping, climbing robots, and everybody was like, wow, Dr. Hong, this is great. But they always say the same thing. But we do not need these robots for our industry. We have green screen, we have CGI. So in the movies industry, they don't need human robots. Until I met the Russo brothers. Now, for this new movie, Electric State, it was a little bit different. So in the movie, they use CGI. However, when the movie comes out at the premiere, on the promotional events, how cool would it be if the robot in the movie actually comes out and greets people? And that's what we did.
Hi, I'm Kid Cosmo.
So we made an actual robot, Cosmo. It can walk, it can wave its hand. It's very, very cute. It was fantastic. We brought it to not only the movie premiere, but Comic-Cons, New York Comic-Cons, to London, to Italy. We've been traveling around the world with this robot. But as you mentioned, most of the robots that we develop are practical robots for research. We have firefighting robots, disaster relief robots. So when the robots move, they need to pick up something. They cannot fall and do things. There are specific motions and task it needs to do. So when you generate the motion, we try to, as engineers and scientists, we try to figure out what's the most efficient, energy efficient or time efficient motion to do. But for a robot for entertainment, it's a completely different type of approach. Because what's the purpose of this robots? It's for entertainment. It's a character in a movie. So how do we portray the character, the characteristics, the personality, if I may say? How do you capture that? That's very difficult or impossible to quantify. So as a robotics researcher, we struggled with doing that. But not only that, let's talk about actual design. So when you design a robot, it's not arbitrary, right? There's a reason why the link length is this high, the ratio, the moment of inertia, the center of gravity location, all these parameters, it's not random. These robots needs to walk and do actual motion in real life. So it needs to follow the rules of physics, F equals ma, all the physical law. It needs to follow that. There's a reason why it's designed like that. But for this one, we didn't design the shape of the robot. It's actually a character in the graphic novel and the movie. So the design was given to us. And I'm sure you saw Cosmo. It has a huge, gigantic yellow head. We love it. It's cute. But as an actual robot, that is a horrible design. Can you imagine a robot walking and it does this and the whole body just, does that? The legs, the ratio, it has huge boots, which make it look really cool. But these are so bad for actual walking. So how do we handle that? That was a very, very difficult challenge. The body is tiny. How do you pack all the components, the battery, the computer, the sensors, the actuators? How do you put all those into this tiny body? That's also difficult. I can go on and on. Oh, one more thing. Among many things, just one more thing. Most, if not all of the industrial robots today, electrical power industrial robots, they use a thing called a servo actuator. So as you know, actuator is the device to make the robot move. Like for you and me or animals, these are muscles. So for these industrial robots, they use a thing called a servo motor. They do position control. They're very stiff. That's why the robot moves like this. They're precise, but they're very stiff. But for a movie actor, for a character, it needs to have this personality. So it cannot move like this. It needs to move like us, fluid and things like that. So we had to develop a new type of actuator called the Bear actuator. By the way, all the robots and technology in our lab are acronyms. Bear stands for Back-Drivable Electromagnetic Actuators for Robots, Bear. So we easy way to say explain is like artificial muscle. So it's compliant and not only the position, but also controls the force. So that's why it's very lifelike motion, just like the character in the movie.
Yeah. And do you see those actuators you developed, having a place in more practical robot designs down the line?
Absolutely. As a matter of fact, we started to develop this Bear actuator before we started this project with Netflix for the electric state. This actuator is actually used for most of our more recent robots. One of the humanoid robots called Artemis that we developed in our lab is what we announced it was the world's fastest walking robot. It can jump, it can run, but it's also the world champ is an autonomous robot soccer. It plays soccer too.
I was gonna say I want to hear about your many soccer wins for your robots.
Yeah, so I'll talk about it in a minute, but all these robots, we use this new type of Bear actuator, and that's one of the key technology to enable these robots to use outside the structured environment, outside the lab. You can interact with people safely and also walk on uneven terrain. So these type of new actuator I think it's a breakthrough technology.
Tell me more about humanoid robots in your lab. What interests you about a robot having a humanoid shape? Why is that worth pursuing? And what successes have you had, including in soccer tournaments?
So again, I started dreaming about becoming a robot scientist watching Star Wars. C-3PO, I was inspired by that. But also, let's start with R2-D2. R2-D2 looks very strange and odd. It's like a trash can with a dome with 3 arms or legs, whatever you call it, 3 limbs. And in the movie, it can roll with wheels, can walk with 3 legs, it can tiptoe, can walk with 2 legs. We call this a multimodal locomotion, or novel ways of making a robot move. So in our lab, we developed more than 40 different type of shape and size configuration robots inspired by R2D2 to do that. But another half of the robots are humanoid robots. And I think I was inspired by C-3PO. C-3PO has been living and working with humans in this environment, helping people. And I think I was really moved by that. So why do we need humanoid robots? Trying to make robots walk with 2 feet, very difficult. Trying to make human hands, very, very challenging. Now, the famous architect Louis Sullivan once said, form follows function, which means that a shape of an object is dictated by what it needs to do. So instead of asking why we need humanoid robots, let's change the question. What kind of task requires the human shape and size? Now, I have a dream. In the future, I would like to be living with robots in our house, doing the dishes, taking out the trash, all these everyday things. Now, I claim that the robot needs to be human shape and size to do that because this environment, look around, stairs is a certain height for humans to walk up. Your door handle is a certain height to open up the door for humans. So unless the robot is human shape and size, it won't be able to navigate this environment designed for humans or even use tools designed for humans. So that's one reason why I'm doing humanoid robots. There's another reason. Do you have a robotic vacuum cleaner at your home?
I have had one before.
Okay.
It broke, but yeah.
Robots. But does it look like a janitor?
No,
it
it's
does
one
not,
of those
right?
little discs.
Yeah, it looks like a big puck, hockey puck. Why is it that? Because that's the optimal shape and size. It needs to avoid obstacles. It needs to go under a desk. So that's the right shape and size. So in other words, if it's a single tasker, you optimize the shape and configuration for that task. But if you need something that's a multitasker, can do many things, then that's when we need humanoid robots. So not only for moving in the house and the human environment, but disaster relief situation. We developed a robot called Thor, tactical hazardous operations robot for disaster relief. You probably remember the Fukushima Daiichi nuclear power plant accident in Japan. If there's a accident in a nuclear power plant because of the radiation, people cannot go. So what do? We design and build these humanoid robots to rescue people and fix things. So there's many reasons why we want to have humanoid robots. And of course, it's cute, fun. We get to relate. And in this case, Electric Steak, the robot is a humanoid shape. So that's why we did it.
Very cool. And tell me more about, why there are soccer competitions for robots and how you guys won.
Yeah. We've been developing humanoid robots for the past 20 years. We started with a small humanoid called Darwin, dynamic anthropoid robot with intelligence. We made it completely open source. So all the CAD files, the blueprints, where to buy the material, components, software, everything's online. It's one of the most widely used humanoid robots in the world for research and education. We also developed a robot called Charlie, cognitive humanoid autonomous robot learning intelligence. It's considered the United States' very first full-size humanoid robot. And I mentioned about Thor for disaster relief and many, many different type of humanoid robots. But the latest and greatest, besides Kit Cosmo, is called Artemis. Artemis stands for Advanced Robotics Technology with Enhanced Mobility and Improved Stability. Artemis. It's as I mentioned, when we first introduced it was the world's fastest walking robot. It was the very first running robot from academia. And it's amazing. You really push it, shove it. You cannot make it fall down. But we also use it for, as you asked, for soccer. So there are actually hundreds of different type of robotics competitions in the world today. But among them, there's a competition called RoboCup. We're a big fan of RoboCup. RoboCup is an international autonomous soccer competition where teams from all around the world develop robots and they play soccer against each other. Not remote control, but they look around, they search for the ball, they do team play, and actually they play a game of soccer. The cool thing about this competition is the official goal of RoboCup is by the year 2050, have a team of robots play soccer against the human World Cup champions and win. We participated in Robo from a long, long time ago. We've been a 5-time world champions till 9 years ago. And we said, hey, we won too many times. Now we want to give other teams opportunities to win. So we're not going to go participate in Robo Cup until in the future, when we develop something completely different and new that gonna make your jaw drop, then we're gonna enter Robo Cup. And that was last year. So we brought Artemis to Robo Cup, and of course, we win again. By the way, since then, Artemis now is a different acronym. Artemis stands for a robot that exceeds Messi in soccer. Artemis.
I love that. One of the things that I think is so cool about your lab is that, in addition to creating these really ambitious humanoid robots, you also have robots that have really novel forms. I know you have one that the body is a helium balloon, and then it has these very twig-like legs. Could you tell us about some of your favorite designs that go totally in the other direction and really are about function?
Absolutely. So as I mentioned, we have jumping, rolling, climbing robots, everting, turning stuff inside out robots, all different things. So very, very creative, different type of approaches. Now, the robot that you mentioned is called BALU, Buoyancy Assisted Lightweight Leg Unit. Humanoid robots in the early stages, they're slow, they fall down, they're complex, they're expensive, and they're dangerous. I mentioned why we need humanoid robots, but there's so many different problems with these. So we've been doing some brainstorming session on how to solve these problems. During this brainstorming sessions, we always try to ask ourselves ridiculous questions. That ridiculous answer comes out, and sometimes from those ridiculous answers, something really creative idea pops out. In this case, we ask ourselves, what if we can change the direction of gravity? How can you do that? It's possible. We ask ourselves these questions. That led to a new type of humanoid robot or bipedal robot called BALU. The body is a helium balloon. It's a balloon with 2 legs. That's a ridiculous robot, but it cannot fall down. It's the world's safest bipedal robot, most likely, and most likely it's the world's cheapest, lowest cost humanoid robot. And again, I don't know if you're gonna show us a video of it, but it walks elegantly. It's a crazy, cute, wonderful, out of this world robot called BALU.
How is AI factoring into your robotics work and the future of robotics?
AI can mean different things for different people. For our robotics, AI can mean autonomy. These days with this large language models, we have a new concept called large action models. This is a little bit technical, but I think this is kind of important. So I'm going to talk about these two concepts. So I talked about this Artemis humanoid robot. It's a metal robot. It can run, jump. It's a high performance robot. It's a big, tall, heavy robot. And I talked about a robot called BALU, which is basically it's a helium balloon with 2 legs. It doesn't fall down. It's very, very low cost. Now, when we first introduced Artemis humanoid robots, the robotics society, the community was stunned by its performance. And everyone is asking, Dr. Hong, what kind of AI technique have you used? And my answer was, we did not use any AI. As a matter of fact, we couldn't use any AI. The reason is this. Now, everybody uses ChatGPT. It's a text-based chatting AI system. Mm-hmm. What is the data? The data is text, right? You probably know DALL-E. DALL-E is a AI system where you give a prompt and it generates images. You probably know Sora. Give a prompt and it generates a video, right? So to do this, you need to train it with data. For ChatGPT, the data is text. Where do you get the text? Text everywhere. Books, internet, everywhere. For images, where do you get the images? Digital cameras, your smartphone. It's on the internet. For Sora AI, where do you get the data of video? It's on YouTube. It's everywhere. So we can train these systems to do that. Can you use the same concept for robotics? Okay, let's do that. Then you need to have the data. But what is the data for robotics? Have you thought about that? Chatbot, it's text. Image creation is images. For a robot, what would that be?
Yeah,
it's the motion, position, acceleration. Not only that, but impact, friction. Where do you get this data? If you search online, do you find this data? No, it does not exist. So we didn't have the data, and it's very difficult to get this huge amount of data. So that's why we couldn't use AI techniques to make it walk for Artemis. Okay. So instead of AI, what do we do? We engineers in the past 100 years, more than 100 years, what we do is we call it model-based approach. So what is model-based approach? We have a physical system. We know the mass properties and all these things. We know the rules of physics. We know science. So we write the equation of motions. We express it using mathematics and use mathematics to control it. We call that model-based approach versus learning-based approach, which is AI. Now, BALU is different. Let's try to do it a model-based approach. We couldn't do that because it's so highly non-linear. When the wind blows, it's so sensitive to different type of conditions. So you cannot, or almost, it's very, very difficult to describe its motion using physics and mathematics. So we couldn't use model-based. But unlike Artemis, this robot does not fall down. So in the lab, 24/7, it's constantly walking in the lab. We have the motion capture camera, and we're extracting data of its motion. So we trained the AI system to make it walk. So this is really interesting. So the important thing is if you have a hammer in your hand, everything looks like a nail. So AI is hot. If you think
Right.
about AI, try to solve every problem using AI, but I don't think that's the right approach. You have to understand the nature of the problem and try to apply the right type of approach. And that's what we did.
That's a really great point. And last question, what excites you about the future of robotics?
Oh, it's robots. How can you not be excited about the future? Every day I wake up, I don't, but I go like, hooray. I'm excited every day. What kind of exciting discoveries will we have? What kind of new ideas will we have? Every day, I'm like a kid at a candy toy store. Yes, there are also, danger of AI and these type of robots, ethical problems. Sure, we are completely aware of those things. But if you think about it, what is technology? What is robotics technology? Yeah, some people define it as sense, plan, act. It's an intelligent machine that does work. For me, the definition of robot for me is an intelligent machine that does things that people cannot do or shouldn't be doing or don't want to do. In other words, robotics is a technology to help people make the world a better place and make people happy. It might sound cheesy, but that's truly what I believe. And this electric state robot, Kid Cosmo, is no different. Is it a robot that actually does helpful work and fixes stuff in your house? No, but it's entertainment. It makes people happy. And I think that is very, very important.
Awesome. Well, thank you so much for joining us today. This has been really fun.
Thank you.
That's all for today's episode. We'll be back with our usual news roundup on Monday. Science Quickly is produced by me, Rachel Feltman, along with Fonda Mwangi, Kelso Harper, Naeem Amarsy, and Jeff DelViscio. Shayna Posses, Emily Makowski, and Aaron Shattuck fact-check our show. Our theme music was composed by Dominic Smith. Subscribe to Scientific American for more up-to-date and in-depth science news. For Science Quickly, this is Rachel Feltman. Have a great weekend.